Multiplying polynomial expressions. So let's do a little reminder of how we multiply variables with exponents. If you have two variables that you're multiplying together and both of them have an exponent on them, all you need to do is combine or add your exponents together. If they are variables with coefficients, you multiply those coefficients together, and again, you still are going to add your exponents. So what does that look like, for example? If I have this problem, negative 3x to the fifth times 4x squared, let's multiply the negative 3 and the 4, our coefficients, which gives us negative 12. And when we multiply the x to the fifth times x squared, what that means is, let me write it out for you really fast so you guys can remember. X times itself 5 times, so there's 5 of them, there are 5 of them, and then we have an x squared, so times x. So how many of those do we have all together? 1, 2, 3, 4, 5, 6, 7. That is why when you're multiplying variables, you just add their exponents together. So this is x to the 7th power. That's the rule, and we learned that in Algebra 1. We also talked about the distributive property in Algebra 1 when you are taking a binomial and multiplying by a monomial. You just have to distribute that term to everything inside your parentheses. All right, so let's do some examples here. We have 3x squared times this polynomial x cubed minus 5x minus 8. So let's distribute. 3x squared times our x cubed gives us a 3x to the 5th power. And then we have 3x squared times this minus 5x. That gives us our minus 15x to the 3rd power. Then we have 3x squared times our minus 8, which gives us a minus 24x squared. Remember that anytime you have a variable and it doesn't look like you have a coefficient, there's always an understood 1. So when we multiplied 3x squared times x cubed, that was just 3 times 1. That was our coefficient. And then when we have a variable and it looks like it doesn't have an exponent, that's just an understood exponent of 1. So when we multiplied our 3x squared times that negative 5x to the 1st power, when we added our 2 and our 1 together, that's where we get this exponent of 3. Just little Algebra 1 reminders. All right, we also have this x plus 3 times 4x minus 9. We did do this in Algebra 1, but let's review, okay? So when I have a binomial times a binomial, that means I need this x multiplied to both terms inside the parentheses, and then I need the 3 multiplied to both terms inside our second parentheses. So let's do that. What is x times 4x? Remember, both of these have an exponent of 1, so when I multiply those together, we get 4x squared. 4x squared. And then x times this minus 9 gives us our minus 9x. And then when we multiply 3 times 4x, that gives us our plus 12x. And then when we have 3 times this minus 9, that gives us our minus 27. Okay? Now, we do have like terms here in the center. We have our negative 9x plus 12x. So those are like terms that we can combine together. All right, so what do we end up with when we simplify this polynomial expression? We get 4x squared, and then when we combine these together, a negative 9x plus 12x gives us a plus 3x, and then our minus 27 on the end. Now, there's something else called a box method that maybe you've seen, maybe you haven't seen. So if you would like to, let me show you the box method, and you get to choose whichever method you like best. So I'm going to create a box, and this is going to be a 2 by 2 box because I have a binomial, which is 2 terms, times 2 terms. And it doesn't matter which set of parentheses you put along the top and which you put along the side. So let's just do x plus 3 right here on the side, and then our 4x minus 9 can go across the top. And to fill in these boxes, so this first box, I'm going to look up and left. What is 4x times x? That gives us 4x squared. Okay, do the next box. So this box right here, I look up and all the way to the left. What is negative 9 times x? That gives us our negative 9x. All right, this box right here, we look up and to the left. 4x times 3 gives us a positive 12x. And I always make sure to put the sign inside the inside the box, just so I remember it's a plus sign, it's a positive. And then the last box right here in the lower right corner, negative 9 times 3, that gives us our minus 27. Okay, now it doesn't matter which order you multiply. You can jump from, this box to this box to this box to this box. It doesn't matter. You can multiply in any order. I just like to do things in patterns the same every time so I don't get confused. So when I look in all 4 of these boxes, I notice that this is an x term and this has an x term. Remember, like terms have the exact same variable and exponent. So I can combine these 2 terms together. And this ends up giving us 4x squared, that's our term with the highest exponent. 12x minus 9x still gives us a plus 3x. And then we have our minus 27. And if you'll notice, both of these answers are exactly the same. You can use whichever method you like. Doesn't matter. All right, let's go to the next one. Now I have a binomial, which is 2 terms, times a trinomial, which is 3 terms. Now, once we get to this many terms, once you get to one of your multipliers being 3 terms, I usually like to stick to the box method because it makes everything nice and neat. Everything gets lined up. Again, it is your decision. If you want to use the distribution method the way that you always have, whatever you like is fine with me. So I'm going to make this box 2 units tall, because again, this is 2 units or 2 variables. And then I'm going to make it 3 units wide or 3 boxes wide. 1, 2, 3, because this is a trinomial. Okay, so down the left side, I'll put a 5x and a plus 1. And across the top, we'll have our x squared minus 4x plus 6. And we'll just go one step at a time, one box at a time. So start here. X squared times 5x gives us 5x to the third. So this is 5x to the third. Next box, negative 4x times 5x gives us a negative 20x squared. So minus 20x squared. Next box, 6 times 5x gives us a plus 30x. All right, and then we can move to the bottom row. This first box right here in the bottom left corner, x squared times 1 is just a plus 1x squared. You don't need to put the 1 if you don't want to. You can if you want to, though. So plus x squared. This box is a negative 4x times 1, which gives us a minus 4x. And then our last box right here, we have a plus 6 times our plus 1, which is just when you're multiplying together a plus 6. So we've multiplied all of our terms together. And again, if you want to double distribute all of your terms like this instead of creating a box method, let me scoot this down. If you would rather double distribute this way, that's fine also. All right. But again, I'm just going to show you guys the box method when we get to these larger polynomial multiplication problems. So let's find like terms. I see that I have x squared terms here and here. So I'm going to highlight those. And then I see I have x terms. I have a 30x and a negative 4x. So I'm going to highlight those in another color. You guys can circle them or you can just look at them. I just think it's visually easier to see. So we've got our 5x cubed. We're going to start with that term with the highest exponent. And then I have an x squared minus the 20x squared. Again, remember this coefficient is a 1. So 1 minus 20, or negative 20 plus 1, that's going to give us a minus 19x squared. And then we have our x terms. 30x minus 4x gives us a plus 26x. And then we have our plus 6 on the end. There you go. Let's do another problem. We have a trinomial times a trinomial. Okay, we have this trinomial times another trinomial. So again, you want to set up your box, but this time it needs to be 3 by 3. This time we need to make this a 3 by 3 box. And you want to make sure that you make your boxes large enough to fit all of your terms and your values. You don't want to squinch everything together so that you can't read it. So the first polynomial expression I'll put on the left side, it's negative 4x squared, our minus 6x, and then plus 8. And then across the top we have, let's use a different color. We have our 3x squared, our plus 5x, and then our minus 7. I just like colors. All right, so first box, 3x squared times a negative 4x squared. That gives us a negative 12x to the 4th power. Negative 12x to the 4th power. Next box, 5x times negative 4x squared gives us a negative 20x cubed. So minus 20x cubed. And then this last box right here, negative 7 times negative 4x squared. That gives us a positive 28x squared. Next row, 3x squared times negative 6x is negative 18x cubed. All right, then this next box right here, 5x times negative 6x gives us a negative 30x squared. Remember, both of these exponents are a 1. So when you multiply x times x, you get an x squared right there. So we have minus 30x squared. Okay, this box is negative 7 times negative 6x gives us a positive 42x. Last row, we have 3x squared times 8. That gives us a plus 24x squared. Plus 24x squared. All right, 5x times 8 gives us plus 40x. And then our last box here is a negative 7 times a positive 8. Negative 7 times positive 8 gives us our minus 56. So this is a nice, neat, clean way. I would probably always use the box method if I were going to multiply these larger values, a trinomial times a trinomial, just because it sets everything up nicely, nice and neat, right? Okay, so let's look for our like terms. I see that I have 2x cubed terms right here. I also see that I have a set of x squared terms here. And of course, I have my x terms here. So let's combine everything together. We start out with a 12x to the 4th power, okay? Now let's look at our blue highlights. Negative 18x cubed minus 20x cubed. That right there gives us a negative 38x cubed. Now let's look at our green section. All of our x squared terms. I see that I have a 28x squared plus 24x squared. What does that give us? 52x squared. So I have 52x squared minus 30x squared. 52 minus 30 gives us 22. So we have plus 22x squared. Plus 22x squared. And then we have our orange section. That 40x plus 42x gives us a plus 82x. And then, of course, our minus 56 on the end. All right, so it's not that it's necessarily difficult. It's just the work. It's a process, and you need to make sure that you keep everything nice and neat. All right, last one. This says 3x minus 5 to the 3rd power. So what does that even mean? It's the same thing as saying 3x minus 5 times 3x minus 5 times 3x minus 5 again. All right, so you're multiplying that binomial times itself 3 times. So we're going to do this in sections. Let's do 3x minus 5 times 3x minus 5 first. And because we're just, because we have to break this apart and it's a binomial times a binomial, let's just do this double distribution first. So 3x, let me highlight first. Hold on, sorry guys. We're going to multiply these two together first. Okay? So what is 3x times 3x? That's going to give us 9x squared. 3x times this minus 5 gives us our minus 15x. Then we have this negative 5 times 3x gives us another minus 15x. And then negative 5 times negative 5 gives us a plus 25. Now all of that is being multiplied by this 3x minus 5 here on the end. Don't forget, we still have this 3x minus 5 here that we have to deal with. So let's simplify the first polynomial, 9x squared minus 15x squared. These two terms, that's not what I meant to say. 9x squared minus 15x plus 25. Let's combine those two middle terms. We have a 9x squared. Then we have our minus 30x plus 25 times our 3x minus 5 there on the end. Again, because I have a trinomial that I'm multiplying by, I'm going to go ahead and use the box method again, okay? So just because I have more space horizontally than I do vertically, I'm going to put the binomial on the left side. It doesn't matter how you build your box, okay? You can make it horizontal or you can make it vertical. It doesn't matter. It's a matter of preference. It's whatever you guys want to do, okay? You could have gone 3 this way, 2 that way, whatever you want. All right, so I'm going to put the 3x minus 5, this right here, along the left edge. And then I'll put, let's do blue, this trinomial, 9x squared minus 30x plus 25 across the top. I usually like to work horizontally for these. All right, so let's fill this in very quickly. So we have 9x squared times 3x. That gives us a 27x cubed. 27x cubed. Then we have a negative 30x times 3 gives us a negative 90x squared. So minus 90x squared. Then here in this box, we have 25 times 3x, so 3/4, that's 75. So 75x. Then we move down here to this row, 9x squared times 5 gives us a negative 45x squared. And then, of course, we have here a negative 30x times negative 5. That gives us a positive 150x. So plus 150x. And then in this last box right here, we have positive 25 times negative 5. That gives us a negative 125. Just a little tip, you guys. Anytime you're multiplying by 25, think of quarters, 25 cents. If I have 25 cents, so quarters, and I have 5 of them, that's $1.25, right? That's how you can get the 125 quickly. Just kind of a little trick to help you with multiplication. All right, so what can we combine together? I see that I have like terms here, and I also have like terms here. All right, so we end up with 27x cubed, and then our negative 45x squared minus 90x squared gives us a negative 135x squared. And then our green section, 150x plus 75x, that gives us a plus 225x. And then we have minus 125. So this one took a little bit more work because we had to multiply 3 different binomials together. Now, there is a shortcut that I'll make another video for you guys. It's not necessary that you use Pascal's triangle in this shortcut method, but anytime you take a binomial expression to a power greater than 3, you're probably going to want to use it. So be looking for another video to help you with that if you choose to use this shortcut method that I'll teach you guys.